Hello students. In the last session we discussed about the inverse Laplace transform, basic formulas and also the examples based on the multiplication of t raised to n by taking n equal to 1, where the given function f of s is logarithmic function or tan inverse or cot inverse. Such functions we did by using the multiplication of t raised to n formula by taking n equal to 1. And second method we did by using the partial fractions method, when the given function f of s is where the numerator degree of the numerator is less than the denominator and denominator is a product of linear factor or repeated linear factor or quadratic or repeated quadratic. In that case you are using the partial fractions method. And we did two example where in the first example where we can write the denominator as a product of linear factor, and we did the second example where the denominator is a product of linear and repeated linear factor. Now we will do the third example where the denominator is a product of linear and quadratic. Yes. Now we will do the third example. Let your function is 5s plus 3 divided by s minus 1 linear factor into quadratic factor s square plus 2s plus 5. Here the degree of the numerator is 1, the degree of the denominator is 3. Degree of the numerator is less than the denominator and denominator is a product of linear factor s minus 1 and quadratic factor s square plus 2s plus 5. You can use the partial fractions method. We know how to write this one. For linear factor it is constant divided by linear factor s minus 1, a divided by s minus 1. Quadratic factor you are writing the linear factor bs plus c divided by quadratic factor s square plus 2s plus 5. We know how to find the constant values. Here three constant values a, b and c. Now simplify by taking LCM. 5s plus 3 equal to a into s square plus 2s plus 5 plus bs plus c into s minus 1. Now again simplify this one. 5s plus 3 a s square plus 2as plus 5a plus bs square minus bs minus bs square minus bs plus cs minus c. Now again if you simplify 5s plus 3, if you take s square as common, coefficient of s square a plus b into s square. Next how we will write the coefficient of s, second term and Bs and Cs plus 2a minus b plus c into s, coefficient of s, then constant term plus 5a minus c, 5a minus c. Now equate the corresponding coefficient. By equating the corresponding coefficient, coefficient of s square, coefficient of s, then constant. What is coefficient of s square? In RHS it is a plus b. In LHS there is no s square, coefficient of s square. There is no s square, you can put it as 0. Next, coefficient of s in RHS 2a minus b plus c. In LHS coefficient of s is 5, we can write it as 5. Then constant term RHS is 5a minus c. In LHS constant term is 3. Now 3 equations, 3 unknowns. Just by using the calculator you can able to get the value of a, b and c. You can use the calculator, 3 equations and 3 unknowns. Yes, what you will get? The a value. Here a value you will got 1. What about b? B is minus 1. Then c value, that is 2. We got all the 3 constant values a, b and c. Here you can use the calculator, 3 equations, 3 unknowns, we will get all the 3 unknown a, b and c. For the quadratic factor, how you are finding? Just equating the corresponding coefficients, we will get all the constant values. Now you substitute the constant values a, b and c. What will get? A, b and c. Now if you substitute the values of a as 1 and b as minus 1 and c value as 2, 5s plus 3 divided by s minus 1, s square plus 2s plus 5 is equal to a divided by a is 1 divided by s minus 1 plus b is minus 1 s plus c value 2 divided by s square plus 2s plus 5. Now take the inverse Laplace transform on both sides. What happens then? L inverse of 5s plus 3 divided by s minus 1, s square plus 2s plus 5. Then what about RHS? Taking inverse Laplace transform on both sides. First term L inverse of s minus 1, second term plus L inverse of minus s plus 2 divided by s square plus 2s plus 5. Yes. Now first term, easily we can find the inverse Laplace transform by using one of the standard formula, L inverse of 1 divided by s minus a, it is e raised to at. As we know, L inverse of 1 divided by s minus a is e raised to at. Therefore, the first term is e raised to t plus L inverse of, how to find the inverse Laplace transform? Here it is not in this standard form of any of the formula. Now here it is both numerator is linear, denominator is quadratic. First you have to make the denominator as a perfect square. We know how to make it as a perfect square, that is s square plus 2s plus 5. How to make it as a perfect square? Now the coefficient of s square already it is unity, and coefficient of s divided by 2, 2 by 2 it is 1, then add and subtract by 1, then what you will get? S square plus 2s plus 5 plus 1 minus 1, add and subtract by 1. Now what you will get? S square plus 2s plus 1, we can write it as s plus 1 whole square, then 5 minus 1, we can write it as plus 4. So that denominator we can write as a perfect square, s plus 1 whole square plus 4. What about the numerator? Numerator s is there. Now you have to write s in terms of s plus 1. You have to make adjustment in the function. Numerator s is there. You have to make s as in the denominator. Denominator it is s plus 1 is there. So you have to make numerator also s plus 1. Now it is minus s minus 1, minus 1, then plus 1, then minus s minus 1 plus 1, you will get minus s, then plus 2 constant as it is. Now it is totally 1 plus 2, it is 3 constant. You can split into 2 terms. Now it is e raised to t plus you can split into 2 terms, plus into minus, you can write it as minus L inverse of s plus 1 divided by s plus 1 whole square plus 4, you can write it as 2 square. Now the second term 1 plus 2, it is 3 plus 3 constant, you can take it outside the operator, it is 1 divided by s plus 1 whole square plus 2 square. For linear by quadratic, here you have to make the denominator as a perfect square and make numerator s. If it is s is there, you have to make s as in the denominator. That means you have to make adjustment in the function, then split into 2 terms. Now this reduces to the standard form. First term as it is e raised to t minus, what is this is standard form, L inverse of s plus 1 divided by s plus 1 whole square plus b square. As we did in the previous session, standard formula by using the first shifting property. By using the first shifting property, we learnt 5 formulas. Out of them, one of them is L inverse of s minus a divided by s minus a whole square plus b square. It is e raised to at cos bt. Then another standard one, L inverse of 1 divided by s minus a whole square plus b square, e raised to at sin bt divided by b. Therefore, by using this formula, we can s minus a divided by s minus a whole square plus b square. First formula, e raised to minus t cos 2t. A is minus 1 and b is 2 plus 3. Second one, it is 1 divided by s minus a whole square plus b square. Second formula, it is e raised to minus t sin 2t divided by 2. Like this, you have to find the inverse Laplace transform. This is by using the partial fractions method. This is the second method to find the inverse Laplace transform. Next, we will go to the third method by using the cannulation theorem. Yes, by using the cannulation theorem. What is this cannulation theorem? Now, the cannulation theorem is if L inverse of F1s is F1t and L inverse of F2s is F2t, then L inverse of F1s into F2s, it is integration of 0 to t F1u F2t minus u du. What it means? What is this cannulation theorem? And when you have to use this formula. Now, the cannulation theorem, this is the third one, cannulation theorem. If you consider the first function L inverse of F1s is F1t and second function L inverse of F2s as F2t, then the product F1s into F2s, if you take its inverse Laplace transform product F1s into F2s, if you take its inverse Laplace transform, it is integration 0 to t. Now, the first function t changes to u, first function t changes to u. For the second function t changes to t minus u and integration is with respect to u. This is the formula. Now, when you have to use this formula, when the given function f of s, given function is f of s, when we can express as a product of two function, first function f1s, second function you can take it as f2s. When the given function f of s can be expressed as a product of two functions, in that case you can use the cannulation theorem. As in integral calculus, in integration for the product of two functions, we are using integration by parts, and here for the product of two function, to find the inverse Laplace transform, we are using the cannulation theorem. Yes, now we will do the some of the examples based on this cannulation theorem. What is the examples? Find the inverse Laplace transform of the following functions. First one, 1 divided by s square plus a square whole square. Second one, s divided by s square plus a square whole square. Third one, s square divided by s square plus a square whole square. Fourth, 1 divided by s square plus a square into s square plus b square. Fifth, s divided by s square plus a square plus b square, or s square divided by s square plus a square plus b square. Here nowhere it is mentioned you have to use the cannulation theorem. It is just asked find the inverse Laplace transform. Now, here in all these examples you can express as a product of two function. If you consider the first example, s square plus a square whole square, or second one, s divided by s square plus a square whole square, or s square divided by s square plus a square whole square. If you consider the first three examples, here we can write this one as 1 divided by s square plus a square into 1 divided by s square plus a square. That means this is your the given function f of s, you are expressed as product of two function. One is f1s, other one is f2s. Or if you consider the second example, you can write s divided by s square plus a square into 1 divided by s square plus a square. Here you can take any one as the first function, take this one as the first function f1s, this one as the second function. As you like, you can take any one as the first function. Or here if you consider s divided by s square plus a square into s divided by s square plus a square. That means here we can express the given function as a product of two function f1s into f2s. Here you can use the convolution theorem. For the product of two function, you have to use convolution theorem to find its inverse Laplace transform. Yes, now we will do the first example, how to do the example. First example, to find the inverse Laplace transform. First example, let f of s equal to, that is given function, it is 1 divided by s square plus a square whole square. This is your given function. You can express as 1 divided by express s square plus a square into 1 divided by s square plus a square. Now you can take one of them as the first function f1s, another one as second function f2s. Here where f1s is 1 divided by s square plus a square and f2s same function 1 divided by s square plus a square. For the two functions f1s and f2s, first you have to find the inverse Laplace transform, L inverse of f1s, L inverse of 1 divided by s square plus a square. It is, what is the formula, standard formula, L inverse of 1 divided by s square plus a square, it is sin at by a. You can take as f1t. L inverse of f1s is equal to f2t. Similarly, for the second function f2s, for f2s you can take inverse Laplace transform, L inverse of f2s. Now this is L inverse of 1 divided by s square plus a square. It is also same sin at by a by using the standard formula. This is L inverse of f2s, you can take it as f2t. Yes, now for both the functions we got the inverse Laplace transform. Now you can use the convolution theorem. Yes, by using convolution theorem, you have to remember the formula. What is the formula? That is L inverse of f1s into f2s is equal to integration 0 to t, and first function t changes to u, that is f1u. Second function, what is second function? T changes to t minus u, and integration is with respect to u. Now substitute the corresponding values. What is L inverse of 1 divided by s square plus a square into 1 divided by s square plus a square, LHS, RHS integration 0 to t, and first function t changes to u. It is sin au by a. Sin at by a is there, t changes to u, sin au by a. Second function f to t, it is sin of a into t minus u by a. T changes here, sin at is there divided by u, t changes to t minus u, and integration is with respect to u. Now simplify. L inverse of, what is LHS? It is nothing but 1 divided by s square plus a square whole square only. What about RHS? Integration is with respect to u. Denominator a into a square constant, integration 0 to t, it is sin au sin at minus au into du. Now you have to integrate with respect to u. How to do this one? It is a trigonometry function, sin a, sin b formula you have to use. What is sin a, sin b formula? It is 1 by a square integration 0 to t. Sin a, sin b formula, it is 1 by 2 cos of a minus b, minus cos of a plus b into du. Now it is sin a, sin b, trigonometry function 1 by 2 cos of a minus b minus cos of a plus b into du. Now simplify. Now it is 1 by 2a square. 1 by 2 is constant, you can take it outside. Simplify, integration 0 to t. Now it is cos of at minus into minus plus, it become cos of 2au minus at, then minus cos 80 plus au minus au will get cancels into du. Yes, now integrate with respect to u. Integrate with respect to u. What is this? Is simplify. This is 1 by 2a square. 1 by 2a square. Then integration of cos is sin 2au minus at divided by coefficient of u, that is 2a, then minus, here integration is with respect to u is there, with respect to u. What is the constant? Cos at is constant, cos at is constant, integration of, what is this one? Cos at is with respect to u, cos at is constant, integration of 1 du. What is 1 du? That is u from 0 to t, 0 to t. Now substitute upper limit minus lower limit. Now simplify 1 by 2a square. Now the substitute the upper limit. It is sin 2at minus at divided by 2a minus cos 80 into t. This is your upper limit minus lower limit. You sin 0 minus 80 divided by 2a minus cos 80 into 0. Now this is your upper limit minus lower limit. Just simplify, ordinary simplification. This last term 0 into anything is 0. Now simplify, what you will get? 1 by 2a square, it is sin 80 by 2a minus t into cos 80, t into cos 80. Now here it is sin of minus 80, sin of minus theta is minus sin theta, minus into minus it become plus sin 80 by 2a, or it is 1 by 2a square sin 80 by 2a sin 80 by 2a, 2 sin 80 by 2a minus t cos 80, or further you can simplify 1 by 2a square, it is sin 80 by a minus t cos 80. This is your required inverse Laplace transform for the given function. What is your given function? In L inverse of 1 divided by s square plus a square whole square. Like this you have to do the examples. Yes, now we will do the second example. Same type, there is no change in the procedure. Same type, you have to do the examples. Yes, now we will do the example. Second example. What is your second example? Let s divided by s square plus a square whole square. How to express as a product of two functions? You can write it as s divided by s square plus a square into 1 divided by s square plus a square. This is your given function f of s. You express as f1s into f2s, where f1s first function f1s s divided by s square plus a square, and your second function f2s 1 divided by s square plus a square. Now here for both the functions you have to find the inverse Laplace transform. What is L inverse of f1s? It is L inverse of s divided by s square plus a square. What is this one? Cos 80, standard formula. You have to remember the formula. L inverse of s divided by s square plus a square, cos 80. This is your first function f1t. Now similarly, find inverse Laplace transform for the second function, and this is also in the standard form. What is L inverse of 1 divided by s square plus a square? It is sin 80 by a. This is your second function f2t. Now we express the given function f of s as a product of two function, and also we got the inverse Laplace transform for both the functions. Now you can use the formula, convolution theorem formula, you can use it. What is by using convolution theorem. What is the formula? Your formula is L inverse of f1s into f2s is equal to integration 0 to t, and first function t changes to u, second function t changes to t minus u du. Now substitute the corresponding values. Now this is L inverse of s divided by s square plus a square into 1 divided by s square plus a square. You have substituted the value of f1s and f2s. Then RHS part, integration 0 to t, and first function t changes to u cos au, and second function t changes to t minus u. It is sin a into t minus u divided by a du. Now you have substituted the corresponding values. Now simplify. It is L inverse of s divided by s square plus a square whole square. 1 by a is constant, you can take outside the integral sign. Now it is cos au sin at minus au du. You know how to integrate this one with respect to s. It is also trigonometric function. What is cos A sin B formula? What is cos A sin B formula? What is 1 by 2 cos A sin B formula? Sin of A plus B minus sin of A minus B. Therefore, you can write it as 1 by 2 sin of A plus B minus sin of A minus B into du. 1 by 2 sin cos A sin B, 1 by 2 sin of A plus B minus sin of A minus B. Now simplify. Now integration with respect to s, 2 is constant, you can take it outside. 1 by 2a integration 0 to t sin of plus au minus au will get cancels, it is sin at minus, what about this one, sin of au minus at, minus into minus plus au. Therefore, it becomes sin of 2au minus at into du. Now, integrate with respect to u. Now, easily we can integrate with respect to u. With respect to u, what is this first term? Sin at. With respect to u, t is constant. Therefore, sin at is constant, integration of 1 du, that is u. Then second term minus, integration of sin is minus cos, minus into minus, plus cos of 2au minus at divided by coefficient of u, that is very important. Coefficient of u is 2a from 0 to t. Then as usual, you can simplify this one. How to simplify? Upper limit minus lower limit. In place of u, you have to substitute. Now it is sin at into t plus cos 2at minus at by 2a. This is your upper limit minus lower limit, sin at into 0 plus cos 0 minus at by 2a. This is your upper limit minus lower limit. Now, simplify, still further simplify. Now, what you will get? Now, this is 1 by 2a, constant as it is. First term t sin at. What about second term? Cos 2at minus at. It is cos at by 2a. then minus, it is 0 into anything is 0, minus into plus is minus. And what is cos of minus theta? Cos of minus theta is cos theta only. Therefore, we can write cos 80 by 2a. Now, 0 into anything is 0. This is cos of minus theta. Cos of minus theta is cos theta only. But outside minus sign is there. Minus into plus is minus only. Therefore, only it is cos 80 by 2a. Now, the last two terms get cancels. Cos 80 by 2a plus minus get cancels. Now, it is 1 by 2a t sin 80. Therefore, L inverse of S divided by S square plus A square whole square is equal to T sin 80 by 2a. Like this, you have to do the example. Now, in the inverse Laplace transform, only important is memorization of the formula. How to memorize the formula? If you know the Laplace transform formula, definitely you can write the, or we know the inverse Laplace transform. We did the first type by using the multiplication of t raised to n formula by taking n equal to 1, second one partial fractions method, this is the third one by using cannulation theorem. And easily we can identify because here they won't mention any property or any formula, just they will give the find inverse Laplace transform. Here identification is very important. For this cannulation theorem, identification, easily we can make the identification. Function can be expressed, f of s can be expressed as the product of two functions. Take anyone as the first function. F of s equal to f1s into f2s. You can use the cannulation theorem. Same as we are doing in the integration for the product of two function, we are using the integration by parts. For in inverse Laplace transform, for the product of two functions, we are using the cannulation theorem. Then we did partial fractions method. We know when you have to use the partial fractions method. Now, the degree of numerator is less than the degree of denominator, and denominator is product of linear factor or repeated linear factor, or it is quadratic. You can use the partial fractions method. Now, before this one, you use the multiplication of t raised to n formula by taking n equal to 1. We use this formula. Now, for this one, easily we can identify, as I told, identification is easily we can make if it is logarithmic function, given function is the logarithmic function, or tan inverse some function of s, or cot inverse some function of s, then you can use the multiplication of t raised to n formula. Yes, this is how you have to find the inverse Laplace transform for the given functions. In the next session we will do the applications of Laplace transform. One of the main application, as I told, it is finding the solution of linear differential equation. What is applications of Laplace transform? One of the important application is solution of linear differential equation. Okay, in the next class we'll discuss about the applications of Laplace transform. One of the main application is to find the solution of linear differential equation by using the Laplace transform. Okay, we will do it in the next session. Thank you.